You guys go work on it.
How long does it take?
Start simple.
Next. You can't. Let's all here go next.
Okay, can I?
No, you cannot.
I can't. I can't factor anything out of all three of these right now. I always want to try, but I can't, and so I'm stuck. But this kind is really simple. These kind, I mean, either they're going to work easily or they're not. Okay. The reason, how do we know this is so simple when we look at it? What makes us happy when we see a factoring problem like this?
There's only one A.
Okay, A is equal to 1. Good. So the number in front of x squared is a 1. When the number in front of x squared is something other than 1, factoring becomes a little tougher. But when the number in front of x squared is 1, it's very simple. Either it's going to work or it's not, but we'll know right away. Okay? So we know that this is going to, if it factors, it's going to break apart into that template. You can write that down from the beginning. And the question is just, can we find the two magic numbers that multiply to what? Have to multiply to what? Negative 10. And add to 3. Good. Okay. So can you think of two such numbers?
Negative 5 and 2.
Negative 5 and 2.
Nice guess.
Hold it. No, that's not quite right.
Oh.
Positive 5, negative 2. Thank you, sir. Yeah, excellent. Thank you. Okay, yeah, we got them backwards. Positive 5 and negative 2, right? And that's it. We're done. That one's factored. Okay, those kind are easy, right? Almost. Okay, what about that?
Take out 4.
Well, you'd like to find something to take out, but unfortunately, there is nothing that divides into each of those three terms. The 9 kind of messes this up. So the 9's odd, right? Okay, so this is the kind when we've got we have a number in front of x squared. This is that trick that we went through on Friday, right? A times c then split b. So we got to multiply a times c, and that's going to be what the magic numbers must multiply to, right? So what is a times c? 72, right? Because 8 is a, c is 9, so 8 times 9 is 72. They got to multiply to 72 and add to 18.
Okay.
So finding numbers that do that can be a little bit of a challenge, because as soon as you start putting these numbers out in front of x squared, you start getting big numbers that you've got to factor. Now, there's a couple ways you can go about this. I want to kind of give you just some tricks and some tools that'll help you doing this factoring stuff. Okay, now for one thing, what you can always do is you can always factor this into its prime factors, the 72, and then I can use the prime factors to build up a list. Simply build up a list of all the numbers that multiply to 72. So let's do that. So we know, first of all, we know that 72, we got it from multiplying 8 times 9. So let's break this apart into 8 times 9. What does 8 factor into? Is there a prime? Well, I mean, I want to see if I can, I've got to whittle it down piece by piece. 2 times 4, right? Whenever I get to a prime factor, I'll circle it, because I know I'm done. So I get 2 times 4.
2 times 2.
4 factors into 2 times 2. So now I've got prime factors from my 8, and then my 9 factors into 3 and 3, and those are both prime, right? So now I've got a list of all these prime factors. So I can go over here and I can say, okay, I want numbers that are going to be built from that list of products. Right? Those are the prime factors. Let's start with, start small. Start with 2 times whatever, right? So we're going to multiply 2, so I'm going to take one of those 2's away, times whatever I get from the product of those other 4. Well, let's group them easily. How about 2 times 2 is 4, 3 times 3 is 9, 4 times 9 is 36. So I get 2 times 36 is 1. And 72 you probably could have done without this. But some of these get really big, and so this is a good strategy. Now, what about 3? 3, I have to take a 3 away, right? If I'm gonna, 3 is one of my factors, and I'm left with 2 times 2 is 4 times 6 is 24. Can I do 4? Yeah, I can do 4, right? 2 times 2 is 4. And then I'm left with 2 times 3 is 6 times 3 is 18, right? See what I'm doing? Can I do 5?
Yes.
Can I build a 5 out of those?
Yes.
No, can't. So 5 is not a factor of 72. Can I do 6?
Yes.
Take those 2 away, right? And then I'm left with 4 times 3 is 12, right? See how that works? And I can keep going. I could do 8. Well, I did 8, right? 8 times 9. And then once I get to there, though, now I'm done. I'm done, right? Because the very next thing I would do would be 9 times 8, and I just start repeating myself, right?
Yeah.
So that's it. Those are all the possibilities. Now, I did forget 1. 1 times 72, right? Now, if we look at the sums that go with those, if I add up the 2 numbers, because they have to multiply to 72 and add to 18, I want you to notice a trend here. As you do algebra, one of the fringe benefits of doing algebra is that it makes your number sense way, way, way better. When you start, in fact, the same parts of the brain that do number relationships and do algebra. So you get better at this. I want you to start to recognize some of these patterns. Numbers are all about patterns. When I add these up, I get 73. When I add those up, I get 38. When I add those up, I get 27, 22, 18, 17. What do you notice there? Say it again?
That's only the 3's for the right where they both add up to something that goes to 3.
They add up to, well, a lot of those do, but not all of them. Some of them do. But what I'm looking for here is not anything quite that. I mean, just something even simpler. Do you see a trend here? Do you notice? What do you think? Well, there's the answer. Okay, so let's get that out of the way right away. Right, there's the winner, because we want the numbers that add to 18. But now that we got that out of the way, forget about that. And I just want to know, do you see it? Do you see a pattern?
I do.
What's the pattern?
It's 782, 783, 784, 785, right?
Oh, I didn't even notice that.
I
Wow.
plugged that plus
Wow.
that equals.
You guys are you're too smart for your own good. All I'm looking for here is this. And I think I asked kind of a dumb question. I didn't say this in the right way. Notice that when the 2 numbers that I'm multiplying, when the factors of 72 are highly disparate, when one's really big and one's really small, the sum is big, right? 1 and 72, that's as far apart as you can get. The sum is 73. But as the numbers that multiply the factors of 72, as they get closer and closer together, notice that the sums get smaller. Okay. That will always be the case, by the way.
That was your
Okay, now how could that be useful to us? Well, here's how that might be useful. If we know that we want numbers that add to 18, and we're making this list of factors of 72, and we're getting these really big sums, then that tells us, okay, we got to find numbers that are closer together, because these numbers are too far apart. They're adding up to stuff that's too big. And so it tells us we need to move down the list a little bit, right? If we wanted numbers that added to a really big number, we'd want to move up this list, and we could focus, because maybe we don't need to make the whole list. Maybe we could skip down a little bit, right? We're just trying to get the one pair of numbers that work, that multiply to AC, 72 in this case, and add to 18. I don't care about having all those. I just want the one that works. So anything that speeds that process along might be helpful, right? Okay. On your graphing calculators, so you couldn't do this on the non-graphing calculator test, but on the graphing calculator test you could. There is a really handy way to find factors that I want to show you. If we want to find the factors of 72, all you have to do is go to the y equals menu. Let me make sure this is. And then whatever number you're trying to factor, just divide that by x. you know, y1 is 72 divided by x. Now if I go to the table, so if I hit second table, and I scoot all the way up to the top, look what this does. 1 and 72 are factors of 72. 2 and 36 are factors of 72. 3 times 24, 4 times 18, but 5 is lined up with a decimal. That tells us that 5 is not a factor of 72, right? Whenever we get pairs that are both integers, those are factors. 6 times 12, 7 is not. If I go down, 8 times 9 works, 9 times 8 works, etc., right? Okay, so that's kind of nice. Make sense? Okay? All right. Okay, so now let's do the problem. Now we know that 6 and 12 were the winners, right? Those were the numbers that multiplied to AC and added to B. So now, let's split this thing up, right? So now we're going to take that middle term and we're going to split that apart. So this is now going to equal 8x squared plus 12x plus 6x, because 6 and 12 were the magic numbers, right? And so now we get to the split B part. Once we know what the magic numbers are, we're going to take that B term and break it apart into two terms that are the sum of the magic numbers. Okay, does that make sense? It's a little different than what we've done. This process is called factoring by grouping, and it actually is something we'll do more in the future, in other situations even. Okay, so is everybody with me?
Yeah.
Okay? Notice I've got 4 terms now instead of 3. I need 4 because I'm going to group these into groups of 2 groups of 2. So there's my first group, and there's my second group. You may be wondering if it makes any difference if the 12x and the 6x had been flipped around. It makes no difference at all. None. It's going to work both ways. Okay, so now here's the process you go through. And I want you to just follow the flow of this. This is not hard to do, really. There's a couple steps that are at the beginning. You got to think a little bit, and then you can just stop thinking. It's just you just follow the pattern. So I want to take this first group, and I want to factor out the greatest common factor.
4.
Okay, so what is the GCF? What's the biggest thing that I can undistribute from both of those terms? I want the number part and the variable part.
4x.
4x is correct, right? 4 is the biggest number that divides into 8 and 12, but I can only take an x away from each term, because although the first term has an x squared, the second term only has an x to give. So I can only take away the power of x of the weakest term, right? So I can only take away a 4x. Now, what is my leftover factor going to be? After I've taken that away, in other words, 4x times what is 8x squared?
2x.
2x. 4 times 2 is 8. X times x is x squared. If that was a little bit strange, doing it that way, that's the way I prefer to do it. You can always just divide, because factoring is a process of division. When I factor out a greatest common factor, I'm literally just dividing away a 4x. And so I could have just said 8x squared over 4x equals what? Well, 4 over 8 equals 2. I could cancel an x top and bottom and get an x left, right? So there's my 2x. 4x times what is positive 12x? 3. And once again, I could just divide it if I wanted to. I could say 12x divided by 4x. The x's cancel. 12 over 4 is 3. And there's my 3. Okay, either way, doesn't matter. Now it gets really simple. Okay, because now we can just follow a pattern. Now I know that the second group, I'm going to do the same process to the second group. You know, now really pay attention to this thing. You got to really concentrate on this and you'll get it. I'm going to do the same thing to the second group. So the second group has to be broken down into a greatest common factor and a leftover factor. Just like before, okay? But I don't even have to think about it because I know that whatever my leftover factor was from the first group has to be my leftover factor from the second group. I don't even have a choice. So I can automatically, whatever I got there, just write it there, okay? And really the factoring becomes almost, there's nothing to do. So only question you have to ask is, what would I undistribute or factor out to get this result from this? What times 2x is 6x? 3, right? Okay, so now I've got the two groups factored. Now the last thing I have to do, the very last thing, is just write those as a product of factors. Now to do that, I want to remind you all we're doing here. What if I told you to factor? Say we had 2 times x times y minus 3 times y. Can I factor out a greatest common factor for both terms?
Yeah, why?
I could factor out a y, couldn't I? Right? I could pull a y out front, leaving me with what if I take that y away?
2x.
Does everybody see that? I have a common factor of y in each term, each of the two groups. Call that first term we could call group 1, second term we could call group 2. When I divide that y away, I'm left with 2x minus 3. So it factors into y times 2x minus 3. Everybody see that pattern?
Yes.
No big deal. Now, this is the same thing. I've got two groups. I've got my first group plus my second group. We already know that we have a common factor because it had to be that way. We didn't even, 2x plus 3 appears here and here, right? So I could undistribute that. I could take that 2x plus 3 and undistribute it from the first group and the second group, aka factor it out. So I've got 2x plus 3. Now what is left behind when I take that common factor and undistribute it? 4x plus 3. Everybody see that? Done. That's it. Okay? We're done. Does that make sense?
Yes.
Okay. Okay, last issue, and I won't even take you through this. We're pretty much done. But I want you just to see something here. Okay, now, what would your strategy be here? Because this is going to be ugly. If I'm gonna try to factor this, a times c, 20 times negative 18, is negative 360. Okay, now I want you to think about this for a second. I want to find numbers that multiply to negative 360 and add to positive 9, right? So what can you tell me about the signs of those? One's positive and one's negative. Which one's bigger? Positive's a little bit bigger, right? And so all I've got to do, I've got to make a list of factors, positive and negative, that multiply to negative 360 and add to 9. Okay, now I can do that. I could break this 360 down into prime factors if I want to, like I did before, to help me make that list. But ultimately, I'm just going to have to do this. My list is going to look something like this. 360 times negative 1 equals negative 360. But that's no good because those add up to positive 359. That's a little too big. We need them to add to 9. So that tells me I need these numbers to start to get closer and closer together, right? So maybe we could skip down the list a little bit. Maybe we could skip down to like, I don't know, 36 and 10, right? What if I did positive, we go down the list, positive 36 and negative 10. What would those add to? Okay, 26. Okay, so we're getting closer. That's closer to 9, but we're still not there. Now, if I went all the way down to positive 20 and negative 18, those add up to positive 2. That's too small. So I got to be somewhere in between. I can kind of narrow it down, though, can't I?
No.
Right?
No.
See how that works? 18 and 9, I'm hearing? I don't think that works. But I could do But I could do something like this. I could go, let's see, what could I do? 36 and 10, I could probably do something like 24. 24 is going to go in, does that go into, but anyway, I mean, we gotta find the ones that go in between, right? Now I could break this up into its simplest factors, 20 and 18. I could split 20 up into 2 times 2 times 5, right? 18 I could split up into 3 times 3 times 2. There's my prime factors. I could use those to build those numbers in between. We won't go through. I'll let you go work. But you get the idea? Okay, the other thing. What would you do here? Not there. Well, actually, there is something here.
Shut up.
If I tell you to factor this, it's got an a that's not equal to 1. So what's your first, your first instinct is to do what? A times c, then split b, which would work. But there's something else here. There's something that's going to help. You always, when you're factoring, you always want to see if you can factor out a greatest common factor. Is there something you can undistribute? Because it always makes life so much easier if you can. Does something divide into all 3 of those terms? 2 does. Good. So we could split this up into 2 times 6x squared, what, minus 9x? Plus 5. Much easier numbers to deal with. Now look at this. Now we still are stuck with a times c then split b, but instead of dealing with an a times c of 120, now we just get 30. Much easier, right? So if ac equals 30, can you find 2 numbers that multiply to positive 30 and add to negative 9? What would the signs be?
They're both negative.
Both negative, right? And if we made our list, negative 30 and negative 1, obviously way too big. This is a pretty short list, though. Negative 15, negative 2, they add to negative 17. Too big, right? I could do, let's see, negative 10, negative 3. Those add to negative 13. We're getting closer. But then the only other option is 6 and 5, right?
Yeah.
That's as close as we can get, and those go to negative 11. So does this factor?
No.
No, it doesn't. Okay, and that's all we have to do. We have to just realize that because if I can't find the magic numbers, I don't have to waste any more time with it. I know I'm done. So it did factor a little bit, but this is as much as we could do. So in Moodle, if I told you to factor this, 2 times the quantity 6x squared minus 9x plus 5 is all you could do. Okay? All right, I think we're good for today. 205.